Okay, so here is the situation. You have a rabbit pushing a shopping cart. I don't know why it's doing that. It just is. And these are what you've been given. Or a bunny, I guess, pushing the shopping cart. The bunny, we're just looking at the cart, by the way. The bunny is applying a force, F sub B, to the shopping cart. Notice it's kind of pushing down and over because the cart's accelerating to your left. Okay, the angle of the force of the bunny with the horizontal is theta. Okay, so see the bunny's kind of pushing down at an angle here. I don't know if you can see that, but yeah, bunny pushing at an angle right over here. And M is the mass of the cart, and F is the force of friction. So that means you kind of got some friction pushing back against the bunny pushing. First step, we're going to draw a free body diagram. So we notice that this cart, even though I cut off the wheels, is in fact on a surface. So I want to indicate that. I'm going to draw a dotted line to show a surface. Now, this is a mess. I'm not drawing all of this. I'm just going to draw the center, kind of like here. I'm going to draw a circle to show the center of the cart. So that's my cart right there. Now we know this is on Earth, and that you're going to have, actually I want to do, yeah, this is fine. I'll do, this is going to be an arrow pointing down, and that is going to be the mass of your cart and how it's being acted on by your acceleration due to gravity. So this mg is actually the weight of your cart, mass times acceleration due to gravity. Now, this is a problem. You have your force of your bunny right here, and it's pushing down at an angle on your cart. And you know that you need to draw these arrows away from your shape, like coming out of it. You don't want to draw it like, I don't know, you don't want to draw them pointing in. Some places say that's okay, it's really not. So you draw this coming out. So it's actually okay to take this arrow that would go in like this and just move it here as long as it's the same length that it would have been. All right, and that it is pointing the same direction. And the good thing about having already drawn your surface here is that now you have, that will be, I'm going to just draw a line and say that is theta. You can do that whenever you can kind of draw an arrow pointing up that the angle is theta. If my arrow will stay on here. So that's my arrow, and that's that angle that this makes with the surface, which would be the horizontal, is theta. So we've got, and this force itself is going to be F sub B, the force applied by the bunny. So I'm going to put a check there. I have my theta. I've dealt with my mass. Now the only other thing to deal with is the force of friction, which would be actually probably not that big since this is accelerating and pointing in this direction. So that would be your force of friction. And what I'm going to do with these real quick, I think I'm going to do my forces in gray. So this right here, pointing downwards, is the force of your bunny. Okay. Right, like that. And then your force of friction would go this way. Ooh, that's an arrow. Force of friction. Very short that way. Now, the only other thing with this is that you do still have the surface pushing up on it, up on this whole thing. Now, you're already going to have the surface pushing up just as much as your weight, so I'm going to draw one that's even with your weight. Now, think about it. You have a bunny pushing on your shoulders, right? It's going to actually feel like you are a little bit heavier, just you have a rabbit pushing down. So it's actually going to push you down into the floor a little bit more, so that's going to that's going to make the floor push up a little bit more on you. So this is going to be your normal force. So your normal force that's pushing back up against your weight, but it's actually going to be a little bit more than that because it's going to have to counteract this component of your force of your rabbit. I'm not going to do my components on my free body diagrams. Let me draw this a little bit bigger over here. So you got your horizontal, right? And you have your, I'm just going to look at the one force. I've got my force of the bunny. All right, we have your theta. So just drawing this a little bit bigger. Now you know that that's going to have two components because this is pushing, this bunny's pushing over, which is actually accelerating it up here. And the bunny is also pushing down. So what this is just going to be a part of the bunny force, and it's closest to the angle. So that's going to be cosine theta. And then this one's on the other side. So this is the force of the bunny, sine theta. So you have these two kind of forces that are acting on the cart. So you know that your normal force actually can't be just the same size as the weight. It's going to have to be bigger. It's going to have to actually be the same as if you added together your force sine theta, force bunny sine theta, and your weight. So this is going to be a lot taller. And that might look like at first glance that you're accelerating upwards, but you're really not. And I will talk about that in the next video.